differentiability video number 1. Okay, show that the function given by m equal fifth root of x, right, has a vertical tangent at x equals 0. Okay, to have a vertical tangent, so we have to find the derivative, right? This means we have to find the limit as h approaches 0 plus of, right? This is m of x. So it's m of x plus h, and x is 0 because x equals 0, plus h minus m of x over h is equal limit as h approaches 0 plus of m of 0 plus h is h, so m of h is fifth root of h minus fifth root of 0, which is 0 over h, which is limit of fifth root of h over h as h approaches 0 plus. If we substitute 0 instead of h, we got 0 over 0, so we have to continue. We should change the form, then rationalize the numerator by multiplying both numerator and denominator by what? By fifth root of h to power 4. To rationalize the numerator, 5 minus power 1, it's power 4. In the numerator, fifth root of h times fifth root of h power 4, we got fifth root of h power 5, which is h over h multiplied also with fifth root of h to power 4. This is h over h cancel. The answer is limit as h approaches 0 plus of what? Of 1 over fifth root of h. Now substitute 0 plus, it's 1 over 0 plus, and we all know what is that mean. This means it's plus infinity. Same, the limit as h approaches 0 minus of the same thing, which you're gonna get the same answer, which is 1 over fifth root of h to power 4. I forgot power 4 over here, otherwise, okay, I forgot power 4, otherwise here we can't do it because 0 minus is negative number, it will be minus infinity, same, but it is h power 4, I forgot the power 4 over there. Now we substitute, it's gonna be 1 over 0 plus, and 1 over 0 plus is also plus infinity. What does that mean? Simply, it means we don't have limits not exist, right? It's not differentiable. It is not differentiable. Okay, what else? We have vertical tangent, right? Therefore, at both sides of 0 plus or 0, at both sides of x equals 0, because we took the h 0 plus and 0 minus, at both sides of x equals 0, we have the secant, we don't have differentiability. This means it has a corner point, both of the parts of, sorry, here, as you can see, it's fifth root of x, right? It doesn't look like a straight line for sure, but it is some curve, a rational curve, but we don't have differentiability. This means vertical tangent at x equal to 0. All right, let me do another problem. Given f of x is equal to 5x. All right, we need to find f prime of x. Starting from definition, then we find f prime of 3. Okay, starting from definition, we know what is that. How we do that, right? It's limit as h approaches 0 of f of x, right, plus h minus f of x over h. This is the f prime. This is f prime of x starting from definition. So its limit as h approaches 0 of f of x plus h 5 instead of x plus h minus f of x means 5x over h, which is equal to limit as h approaches 0 of 5x minus plus 5h minus 5x over h. 5x minus 5x cancel. What left is 5h over h, so we can simplify, right? What left is 5. Now, what is the derivative at 3? Since we don't have in the derivative, this is the derivative, we don't have x to replace, so constant derivative. This means whatever x is gonna be 5 because it's constant derivative. Again, starting from definition of derivatives, prove that the derivative of cosine x is minus sine x. Derivative of cosine x is minus sine x. If f of x equal cosine x, we need to prove that the derivative is minus sine x. We know it is minus sine x, but we need to prove it starting from definition. Nice. Starting from definition, again, the f prime of x is gonna be limit as h approaches 0 of f of x plus h minus f of x over h. This is the definition. So its limit as h approaches 0 of what is f of x plus h? It's cosine x plus h minus what is f of x? It's already cosine x over h. So it is equal to, let me do it downwards. All right, it's equal to limit as h approaches 0. What is cosine x plus h equals to? This is a rule. It's cosine a plus b. Cosine a plus b is cosine a cosine b minus sine a sine b, where h is b and x is the a. Minus cosine x, we leave it, and over h. We notice that the first term cosine x cosine h and the last term minus cosine x, there is a common cosine x between them. So I'll take it. It's cosine x cosine h over cosine x. What left is cosine h minus cosine x over cosine x. It's 1, right? Minus sine x sine h, we leave it. Sine x sine h over h as h approaches 0 for sure. Again, limit as h approaches 0 of what? Okay, let me distribute the limit, right? Cosine x, because it's minus summation, we can distribute, right? This one alone, minus limit again as h approaches 0 of the other part, which is sine x minus sine x times sine h over h, right? Which is equal. Cosine x is, we can consider it as and sine x, we can consider them as constants because h approaches 0, so we can take them outside the limit, right? Cosine x multiplied with limit as h approaches 0 of what left is cosine h minus 1 over h, minus 1 over h, minus sine x outside, right? Multiplied with the limit of sine h over h when we take the sign outside. That's nice because this is a formula. It's equal to 0. And this is a formula. Is equal to 1 when h approaches 0. 0 times cosine x is 0 minus sine x. And the final answer is going to be minus sine x. Done. Another problem. Okay. Another one. Let's start with this one. Consider the function f of x equal, this one is very nice, f of x equal 6x minus 4 if x is less than 1, and 5 minus 3x if x is greater than or equal to 1. Show that f is not differentiable at x equal 1 and has a corner point whose coordinates are to be determined. All right, same, since we need to study the differentiability and to see if it is differentiable or not, this means we have to find the differentiability to test the differentiable rule at h tends approaches 0 plus and as h approaches 0 minus. And where x equal 1, right? Here we have at x equal 1. So its limit of f of 1 plus h, right? Minus f of 1 over h, which is equal. Limit as h approaches 0 plus f of 1 plus h which one we have to take? It's h approaches 0 plus means 1 plus 4x. This means this one 5 minus 3x, but we don't have x, so it's 5 minus 3 instead of x1 plus h minus f of 1. Also we take it over here because x equal to 1. It's 5 minus 3 times 1, which is 3 over h, equal to limit as h approaches 0 plus of 5 minus 3h minus 2. 5 minus 3 is 2 over h, and 5 minus 3 is 2, minus 2 is 0. We can simplify them because we have just one factor up over one factor down, right? So the answer is going to be minus 3. Let's test what we have to the left of h. 0 minus means to the left of 1 with respect to x. The same, f of 1 plus h minus f of 1 over h, which is equal to limit as h approaches 0 minus of, right, 5 minus 3 instead of x, 1 plus h minus, no, not this one, because we have h 0 minus means x 1 minus, so we have to take it and over here 6 into 1 plus h, right, instead of x, minus 4 and minus f of 1. F of 1 is the same one, which is minus 2, we found it over here, over h, which is equal to limit as h approaches 0 minus of 6 plus 6h minus 6 over h. 6 minus 6, 0. H over h, we can simplify it, so the answer is 6. Since those two limits at 0 as h approaches 0 plus does not equal to the limit as 0 as h approaches to 0 minus, this means what? This means f is not differentiable. F is not differentiable, right? At x equal 1. So at x equal 1, what do we have? By the way, those are two straight lines, not the one we did before. So it looks like something like that. So yes, we have corner point. It is continuous, but it's not differentiable. This means we have corner point. What is the abscissa of this corner point? Since we said at x equal 1, so it is 1. What is the ordinate? It's f of 1. And we found f of 1, which is 2, right? This means my corner point is 1 abscissa, 2 ordinate. The corner point, done.